Hey everyone, I'm going live at I think exactly the right time right now. Hopefully you can hear me. It looks like my audio levels are good. Looks like the stream is correct, and it looks like what I want on the screen is good. So just let me know if you have any comments about my current setup. And otherwise, I'm going to get started in just a moment here. I am looking at the live stream, live chat. There we go. Good. All right. Thanks for letting me know. And I tried to do the thing with the overlay, but it doesn't always work for me where it's going to show what the live stream comments are on the video itself. So if you're watching this in the future and those aren't working, then you'll just have to use the live replay feature that YouTube allows for. And you just heard the sound of the drink that I'm going to be drinking while I am doing this today. So I've got this Raspberry Pi board here. It's a Raspberry Pi 2, so it's relatively old. But that's all right because it's the spare one that I had. I have a Raspberry Pi 4 as well, but I didn't want to use it on this project. And I've got this breadboard attached to it. Now, I've got a 9-axis position sensor. It's supposed to be able to do magnet, accelerometer, and what's the other thing? Well, whatever. So it's to be able to tell exactly wherever I am in space, pretty much, except for not a GPS, but and within its own orientation. And then I've got a 32 by 128 OLED display, which you can see is currently displaying something. That is just a proof of concept to make sure that this is doing something that I can actually talk to it. Gyroscope, thank you. Yes, that's the other axis. And then I've got a real-time clock with an Eeprom chip on it. Now, for my actual wiring, I've got this yellow and orange wires here that I've given myself a I2C bus across the top of my breadboard. And so this is the SCL and SDA lines that are coming in here. You can see SCL is the orange, SDA is the yellow. You might be able to see that. And then I've got red and blue down here. I'm using the bottom bus bar for my power. So that's what I have going on at the moment. And then I've got this white line here, and that is to tie the AD0 line down to ground on my multi-axis position sensor thing here. Because if I don't do that, then I can see that the I2C address for it will actually float, because that AD0, if it's tied to ground, then it's going to set the last bit of the address to 0. If it's tied to VCC, then it's going to make the last bit of the address 1. I streamed 2 times included. Yeah, I started by forking the C++ starter project that I have up on my GitHub, and I was just doing some quick cleanups and working on it. So I'm actually doing the development on the Pi itself here. So I am SSH'd into the Pi from my laptop. And I've got, let's see, what else do we have going on here? Okay, let's do this. I2C detect -y, which bus? I need to use bus 1, and I need to use sudo. All right, so I know from my previous experimentation that address 33C is the OLED, and address 68 is the 9-axis position sensor. Now, if I were to change this white wire here to be tied to VCC, then we would see that address change to 69. And 50, I'm slightly confused about, because this is supposed to have 2 I2C devices on it. It's supposed to be both the Eeprom and the real-time clock, and I thought they had different addresses. So I expected to see 2 devices show up from that thing, but I'm only seeing 1 at the moment. I'm not sure. I'm probably missing something. Now, part of the reason I'm doing this stream is it has been a really long time since I've actually done anything with I2C. And I thought that it would be fun to try to get back into that. And I see the number of viewers is going up, but I just did a whole walkthrough. Feel free to rewind and replay this. I should have the DVR feature running here. So I can see that I can talk to these guys, and then I had been already trying to prove that I could talk to the OLED display. I really could not get it to do anything, and it was getting really frustrating. So I found this example project that has actually been deprecated by Adafruit, or Adafruit. Adafruit is how that should be pronounced. But it works. So I am able to, and all these things make me go through sudo right now because I don't have my user in the I2C group, I think is the problem. So I need to be able to open up the I2C device. I can run any of these things and we should see the output change. Yay. So from your perspective, the output is upside down. Now I thought about actually rotating this 180 degrees, and maybe I'll give that a quick try. So the output looks correct to you, but the problem is it's all upside down from my perspective. So if I'm pointing at something, it might be a little bit weird, but I think that's, maybe I'll go with that. No drivers. No. This is not going to be like my legendary Commodore 64 talk. I have no idea what I'm doing. Let's be clear. I don't know what I'm doing. I'm going to be playing with this. The Raspberry Pi has its own I2C device. So, yeah, that's a rotate. So I've got this thing, that was the wrong thing to do now, wasn't it? I've got this device that I can connect to and using standard Linux facilities talk to. So that's what I think is going to be the best option here. I don't have to do any bit banging or GPIO or any of that stuff. So if you go to the video description that you're currently watching and expand the description there, then you'll see this set of links that I copied in. And this is slightly overlapping here. Let's pull that down a little bit. Okay, so I've got all of these links that you have direct access to, and we're going to be starting with the kernel.org one here and see where that gets us for trying to talk to this I2C thing. Now, all of this stuff up here, like I said before, is actually from the example code, for docopt that I copied into my C++ quick start project. All right, so yeah, I just have a blank slate here, a program that I can run. I know which devices I'm going to talk to, and I have the device and I have the examples to look at here. So I'm going to click on that. And then I'm going to look back at the comments here. Yeah, the device, yes, it can flip the contents. So I'm kind of hoping that some of you will be able to help me with actually accessing these devices, because I know I'm totally going to get lost in some places. I'm going to, though, just for the fun of it, do something like this. So that actually is going to show you the live stats for my Raspberry Pi. I don't know if that's legible. Now let's do that one. Maybe we'll leave that one run for a minute while we try to figure out what we're doing. So yeah, this thing totally does work, but I don't know what I'm doing. So like many things, I've decided to do this as a YouTube video so that I learn what I'm doing. I learned something new. Now, going to this kernel.org example, It's just a C example, and there's a couple of Linux kernel headers to include. We've got the I2C device, the SM bus, and it looks like, oh my goodness gracious, just to see all of the C-ness here makes me, we're going to translate this into C++ idioms as much as we can. So we have to open the file that is the particular adapter that we want to open. So this is going to be, in our case, I2C-1. Oh, I should point that out. That's what these two pins are here, right, is the I2C device. There are two I2C devices on our I2C devices on the Raspberry Pis, and device 1 is the one that's recommended to use. Device 0 can only be used if you disable the HDMI interface, I believe, which I'm not really interested in doing at the moment. All right. Oh, and just as an aside too, because I did the rebranding of my channel a few months ago, for those of you who noticed that, I went from being under my own to being a brand account, which is actually called C++ Weekly. My Streamlabs chatbot helper to filter out spam is not necessarily set up as good as it was before. I still do have all of my old moderators. If any one of my old moderators is here at the moment, that you can help me out in keeping this under control if I have a problem with it. But if anything becomes a problem and I don't see it, please let me know, and I will start locking down the chat some more. All right. So let's see, we open the device and then use IO control to say that it's I2C slave and what the address is going to be. That's the address of the device that we want to talk to. And then we can use these read word data, write data kinds of commands. And these are things that say, like, it does all the I2C protocol handling for you. So I can pull up this example. No, that's not the example I wanted. Sorry. I want the OLED driver PDF. And I just realized I don't even know. Good, I do have a PDF viewer I can access easily on here. So this thing can do up to 128 by 64, 128 by 128, something like that. My device is the 128 by 32 one. And if we look at the I2C interface, I2C data format. There we go. So you have to do a start bit and then send the address and then set whether or not it's a read write and do the acknowledgement and then set whether or not it's a continuation bit and so the control bytes and the data bytes and all these things that you want to do with it. But we're going to get some level of abstraction for us from this. Now, I am looking at this file because this is the actual Python code that gets this thing turned on. And it looks like setting this up is not necessarily as trivial as I would like it to be. They seem to start by turning the display off and then setting up a bunch of multiplex, display clock div, and we can see these things in the PDF here. So go to that description, look at the PDF if you want to follow along, and then set some charge pump settings. I don't even know, external VCC, memory modes, set contrast to external VCC, set charge pump to external VCC. Okay. And then set vcom detect. All right. Display all on, resume. So there's a couple of commands here to turn the display on or off or invert the display and that kind of thing also. Now, that's that. I don't know. I kind of want to start with reading the clock from my RTC device because that one looks kind of interesting to me. If you watch my other channel also, and I did a recent episode on BCD, binary coded decimal, it looks like the real-time clock actually uses some form of BCD here. I'm going to scroll down to the data format. So the data format is the first bit is, what is it, the CH bit? I forget what that was now. I was reading this last night. Logical time and date entries are undefined. Bit 7 is the clock halt bit, right? Okay, so if you set the clock halt bit, if I set that bit, then the clock isn't going to be running. But otherwise, it's the bits 6, 5, and 4 are the tens digit for the current number of seconds. Bits 3, 2, 1, and 0 are the seconds digit for the current number of seconds. So, yeah, I mean the ones digit. Whether or not it's AM or PM, 24-hour clock mode, that kind of thing. So I think this might be the easiest thing to read from. So we might start with that and see if we can read what address registers we can read from the RTC using this example code from kernel.org. Oh, my other channel is, what is it called? Someone knows the name of it, right? Oh, Retro Programmer. Links might be allowed. You can give it a try. All right, so I guess I'm just gonna like literally copy and paste this code in so that I have something to compile from to start with. Yeah, just paste the whole thing in here. Oh, that was probably a mistake, wasn't it? Yeah, it was. I didn't put Vim in insert mode first. Interestingly, using NeoVim on a Raspberry Pi 2 is surprisingly slow, but it's also usable at the same time. It's all going to be a little messy at the moment. Yeah, I thought it would be just so much more fun to actually run on the Pi than try to do cross development. That's more, I don't know. I like actually using my Pi as a computer when I play with it. It just, I don't know, it's fun for me. It seems that there's, yeah, I see your comment, by the way, that I could have done the set paste to ignore. But I got... What is going on? Oh, I just had the right brace highlighted. I don't know why I did that. All right. So we have this code that gives us some debug output to start with. This is going to be a bit of a mess. So yeah, I'm looking at your comments, Drew. Just for the record, with a Raspberry Pi 4, it's actually like super fast. And that's my other pi is a 4. I mean, it sounds like, those bumper stickers, my other car is an F16 or something like that. I have every intention. In fact, I recorded an episode on actually using a Raspberry Pi 4 as your dev box, but I haven't edited that because the quality turned out really poor. I think I'm going to redo it again with my new 4K monitor and just prove that it could be done and see how that would work. I even have this set up, by the way, with Conan and everything here. So I think this could be fun. Oops. Wrong device. All right. So that is actually up on my GitHub account if anyone cares to play along at all. But I've got lib format, speed log, whatever going on here. All right, let's look at this. So this is, I'm going to hard code a couple of things here. That is address adapter number 1. And then I want to talk to device that is hex 50. And that's where I set up the IO control as to what the slave address is going to be. Okay. I always use Manjaro because it's so much easier to stay up to date with compilers than it is with other distributions. I haven't had any problem with it. Excuse me. May as well go ahead and use the fact that I have speed log in here. This isn't going to be the best error handling, but at least it'll be something. Speed log is awesome. All right, so device register to access, and the result from reading it is being stored in here. And what is this character buffer of 10? This is C-isms. There's no reason for that variable to be declared up there, even in C. Put them together, people. Also, no reason to do this, even in C. All right. Forgive my ranting. I'm going to comment out the rest of this. No, I'm just going to remove this. We just want to see if we can read a value. And we need to look at what, missing a semicolon on line 82. Line 82. Hey, that's true. Wow, look at that. So handy, group programming. Thanks, everyone. Do I have it on GitHub? Yeah, it's on GitHub. It's on GitHub. Let's just hold down the backspace key for as long as we can. So I am not signed in as me, which is good because I don't want to accidentally expose something here that I shouldn't. My repositories, I2C hacking right here. Updated 4 minutes ago. So I'll push to this from time to time throughout the course of today's stream. I definitely need to stop by 2 o'clock my time. So I've got 2.5 more hours of working on this. And oh, it started as a template fork from CBP Starter Project, which, by the way, the CBP Starter Project, I do have a bunch of open issues and pull requests. I need to get to those. I haven't looked at it in a few months. Sorry about that, if that was from any of you. All right, so we open the device, we set the ioctl address, and then we want to read a register. What register do we want to read? Let's try to read. This is the DS1307. Let's actually make sure that this is the right device address. No, I don't need to know the... I want to know the device address, not the register addresses. Yeah, that's standard I2C protocol stuff. And yeah, I did see a couple of comments about perhaps words that we shouldn't be using today, but there's no way around it at the moment. I must use these words because this is how the protocols are defined at the moment. Slave address byte contains the 7-bit, which is, okay, 110100. All right, let's see, what is that? That is what in hex? That is 1, 2, 4, 8. All right, something 8. Wait, 8? 8 should be the second digit. Or was that? Someone else see what I'm looking at here? Yeah, I see that address. What does that actually works out to? And someone said, you want to know what secret repos I have? Very few of my repos are secret. And yeah. I am just moving, my brain is moving slow here. Wait, not paper mode, not scientific mode. Do I seriously? That is saying that that should be device 68. Is it possible that I actually have 2 devices on the same address? When I should have tied... I'm just going to do this live. That didn't actually change that. No, wait, 60... Yeah. Yeah, everyone agrees. It should be 68. But 68, I am almost positive, is actually this device. I'm gonna just take its power off. Don't cross the streams. Shoot, I wonder if I need to actually restart my Raspberry Pi. Or if that's actually correct, which device I'm talking to now. 50 and 68 actually represent the Eeprom and RTC on here. This is what makes hardware hacking just so much fun. So basically I just attempted to reboot my accelerometer. And it should have set that address 1 to 1, and I should have been getting different results here. All right. Let's look up the docs for this Eeprom real quick and see. Actually, this might be easier. See what the address of the Eeprom is supposed to be, because if it's supposed to be hex 50, then I think I have to reboot my Raspberry Pi. Huh. Look at the comments, sorry. Yes, that blue case is rather convenient. It was a handy find that I found on eBay. I really don't know what I'm looking at. I'm really tempted to reboot the Raspberry Pi right now. Because that's not really going to lose us anything. And we can see, because I know that should have changed the address of this device by changing where I tied AD0 to. And I clearly do not see that actually changing. Unless that is part of my problem. I thought maybe the possibility that this was constantly sending I2C messages, I2C messages. All right, I'm gonna reboot the Pi. That'll be back up in a second. Yeah, I do actually recommend that case, this case, if you have any interest at all in doing this kind of thing. It came with the breadboard and it came with the blue case. I put my own Pi in it. And if you can read this here, it has an Arduino Mega side also here and a Raspberry Pi side. The only real problem is getting the micro SD card in and out here was a bit of a pain because I did have a different device mounted here also. Yeah, it looks like the Eeprom device slave address is configurable. Yeah, but I don't know. All right, that changed absolutely nothing. I'm going to leave this unplugged. And I'm going to give it another reboot because I don't know what let's just take that out of the picture entirely. But then I think we can maybe safely think that the RTC is 50 and the Eeprom, or the RTC is 68 and the Eeprom is 50, I think. So we're going to try reading a couple of bytes from address 68 and see what we find in a moment here. Fortunately, this boots pretty quickly. Why reboot? Because I just want to remove any variables that I don't understand. I shouldn't need to reboot, you're right. But the fact that I'm not seeing, okay, because I know for a fact that this thing was coming up as device 68 when I was experimenting earlier before I added the RTC into the picture. So they might have been an address conflict here. And 3C should be my OLED display. And what am I building? I don't know. I'm just doing stuff. I was looking at your oh, sorry about that. That was probably loud. Looking at your comments saying that I should look at the pinouts on that board, but that's kind of hard to do. The power lines. Yeah, I think that's what I'm looking at. Or 68 is RTC. 50 is, yeah, the Eeprom. That's what... Well, you know what? Let's start reading values and see what we find. So I want to read if this is actually the real-time clock, then the list of oh, look, it just has some RAM available, it seems. That's fun. 56 bytes of RAM available. Those are the timekeeper registers. That's the control register. All right. Well, I'm just going to try reading from address 0 repeatedly and see what happens. Address 0 from the device 68. And I want to read byte data. Word is 16 bits here, I think, in this world. No. You went 8. So if there was no error, wait a minute. If result is less than 0, Well, if the high bit is set, it's going to read as less than 0, so I guess I need to use the 32-bit int that they were using. One of you probably saw that already, huh? Yeah, I know the DS13, wait, DS1307, which one's? Yes. And then the SSD 1780 default address is 68 also. No, not that one, sorry. The, this thing, the MPU 9250A's default address is 68. Oh, and for the person who said that you would start with the display because it's shiny, yeah, it takes a lot of setup. And I want to make sure that I'm actually talking to something before I try to go something fancy like the display. And then I'll try the display next. There's a, what is it? What is it? What is it? All right. It's just OB, right? You all probably saw that while I was not looking at the screen. Oh, right. Colon, right. Now I want binary because I want to see what's going on here. All right. Oh, oops. Yeah, and I know there's going to be at least someone on here, at least in review later, telling me I'm using them wrong, because that's how this always goes. I'm sorry, what? Why don't I have that header? Yeah, why don't I have that header? Where would that be? Yes, the Pi does have a second I2C bus. I mentioned that earlier, but I have to disable the HDMI output to do that, and I just didn't feel like doing that right now. Oh look, I'm not the first person to have encountered this problem. What? Stack Overflow has the answer? How is that possible? No, this isn't actually telling me anything useful, is it? Lib I2C-dev. All right. All right, hopefully this will compile. And so this just should read just the first make sure I get the header right. FCNTL. Should read the first address byte, the first byte. Oh, come on. Oh, right. It's a C header, not a C++ header. And I keep exiting Vim because I'm not paying attention. Oh, yep, and I need ioctl too, as you already saw that. I see in the chat log here. I should not have to link with anything different. These should be all provided by the kernel, but I don't know, by the system libraries. No linking error. Let's give no linking error. Yeah, it is actually really slow to compile on a Raspberry Pi 2. It's really slow. Oh, and there is a linking problem. You're right. What did someone say? Do the apt file? I'm not on Manjaro. I'm on, well, it's not here. Yeah, it should almost be just, yeah, it's Raspbian, which is basically, it seems to be Ubuntu effectively. And I will state for the record that I did have Manjaro. I had full Ubuntu on this originally, but it seemed like all of the documents for doing I2C, I2C programming with on Raspberry Pi, they all start from assuming you have Raspbian. So I'm like, whatever, I'll use Raspbian, fine. Oh, look, Conan has to rerun. I know a lot of you are saying, duh, lib I2C, you just installed it a moment ago, but I swear every time I assume that the thing I'm supposed to link to is whatever name you think it should be, it just never is the thing that you think it should be. And so I am now linking to -l I2C, as you can see here, and I'm still not getting this. So does this kernel.org document tell me what I have to link to get it to work? No, of course it doesn't. And Google. Oh, this was closed 5 years ago. Duh. That's why this is the top one to come up on the search results. Huh? But this isn't useful. I2C dev and I2C core. Oh, and none of you are giving me the answer here. No. Now I'm going to intentionally waste time, I guess. Package config. That's a good point. Does not appear that there is an I2C package config at all. Yeah, I am linking I2C. And see, I'm linking I2C right here. And now linking I2C dev. Okay, now it's getting, yeah, can't find I2C dev, which isn't surprising. case you didn't catch that, the actual problem here is that, well, it's not really a problem for SMBus, it's just a problem for me. I'm using C++. The SMBus header doesn't have a pound if def underscore underscore C++ extern C rigmarole around all of its declarations that we tend to get from our C libraries. So I had to manually wrap that in an extern C here so that the linker knew how to find those functions. Oh, look at that. It seems to be incrementing at approximately 1 unit per second. Yes. All right. Let's do something more interesting here. So I'm reading. What am I reading? I'm reading. This is fun. Okay. I'm reading the seconds. All right. I'm reading the seconds, and it is in something kind of like BCD, and then the minutes is the next value. All right. So if only I had a display to show the time on. Yeah. All right. Maybe we'll get to the display. Okay, so it's funny, whoever just mentioned Simon mentioned the LCD display. I actually have one somewhere. Oh no, maybe I already got rid of it. It was bad. I ordered one and it was bad. And this was a long time ago. And I spent far too much time trying to get an LCD display working that I just wasted my time on. It was so incredibly annoying. Yeah. Yeah, I did that right. No, my RTC, I don't think it has an LED on it. No, it does not seem to have the LED on it. I could just sit here and do this. This is incredibly gratifying. All right. The question, actually, I'm going to wait a few seconds and see if it resets at in 15 seconds, if it actually rolls over like it's supposed to. Yeah, all right, we're definitely reading the correct value. Neat. Zero padded, 2 wide. I'm just gonna get that compiling again. And then we're gonna start extracting some of this out. Yeah, I'm just connecting random stuff. I just saw the message. So right now I am trying to talk to the RTC, and I needed to prove to myself that I could in fact read something from an I2C device on Linux from C++, and I did. We got there. So that's cool. I am not going to personally go any further without making some way of being able to, log an error, whatever, code reuse, that kind of thing. The code reuse is good, right? So this thing says if it reads a value less than 0, then we've got some sort of an error. I'm going to just get some sort of minor something working here. And then maybe I'll get the rest of the display outputting. I love the idea that I have RAM that is readable and writable. We should try writing to the RAM and reading back the value that we just wrote and see if that works. So if I were to read, all right, whatever. I'm just going to use a lambda. It's not the ideal thing here. That's a file pointer, right? File. It's an int. Of course it's an int. It's not an FP. Duh. Seconds and minutes are parsed exactly the same way. All right. East, can I use a struct with a bit field in it? Not in C++, could I? I don't think I can, because I think a struct with a bit field in it is not a standard layout type, and you can't legally copy data in and out of it if it's not a standard layout type. I think that's correct. The compiler should compile this to basically the same thing. It's just a little bit of an annoyance from our perspective. Oh, you know, helps to save before I recompile, doesn't it? So there's an aside here. I really, really want to play with FTX UI and have this as kind of the little window into my world over here that's displaying the things that are coming from that I'm reading in and out of the I2C devices here, and I just think that would be like super fun. But I haven't actually played with FTX UI, and I don't know if I want to make you all sit through that. In the read byte lambda, I used RTC. Yeah, I did that on purpose. I did a quick change. I changed the file value name to RTC. That was on purpose. Oh, inside the lambda. I see. I'm sorry. You caught my mistake and I corrected you incorrectly. All right. I'm tired of these warnings. At some point we'll add command line arguments to this. I don't know. Something. Time field is set but not used. That's because I didn't do that. All right. All right, so let's go back to this, and there is a write byte, and so I'm going to write a quick wrapper around that. Is I'll return 32-bit integer specifically. It says signed 32-bit. Control reaches end of non-void function, right? For lack of a better option at the moment. But that is saying it's been an hour since we last rebooted the real-time clock. That doesn't seem quite right. Did the oscillator stay running in the RTC when I rebooted the Raspberry Pi, which did not reboot the I2C device itself? Oopsie. Shouldn't that be a warning? How does auto work in that case? Not returning from the if and read byte. Yes, okay, right. Yeah, sorry, I guess going back and saying these things that already, it should have been, all return paths must return the same type when using auto return type deduction. There was technically only one return path, so I guess it allowed it, but I wouldn't be surprised if Clang said it was an error. Good old conversion warnings. Conversion from int to uint8t on line 123. That is in fact what is happening here. So this read byte really should be, that is what a byte is, right? I'm gonna go with that here because I don't have, if I just read a byte, I don't have any way of doing this. I could make it an optional, I could make it a variant. I should have used an arrow here, but oops. Yeah. Yeah, why not standard byte? That's a good question. I'm going to stick with UNT because standard byte isn't an arithmetic type. And UNT is. So standard byte's actually a little bit of a pain to work with. And error handling just becomes its own whole thing here that we just don't even know. I don't care what the specific type is here. This type, I kind of do care. No, I don't because I'm static casting it. Do that. Difference between, the difference between arithmetic and non-arithmetic types is you can't do arithmetic. Yes, that's correct. The line 119 is intentional because I'm only reading the top 3 bits of these fields right here. Or not the top 3 bits, but I don't need the 8th bit here, and reading the 8th bit here could be just potentially wrong. So I want these 3 bits, which can be the values, as someone else pointed it out, 0 through 6. So, well, it could be values 0 through 7, but as far as time goes, this is my allowed range here for both of these. For our minutes and seconds. And then hours is going to be its whole own thing. Is the 10-hour bit set? And is it currently... So I need to see, yeah, and it's so we probably won't get to the point of setting the hour, sorry, the 24-hour mode or not. Does make me wonder what the default setting is, though. Oh, all right, that's minutes and seconds. I should read the hours, and then I'll move on to something else. I don't know, unless you're having fun. with seconds equals 60 happening only for leap seconds. You wrap the timekeeper registers and then add an interface that doesn't use raw numbers to read and write specific. Yes, I definitely just, yeah, all kinds of things. I'm just trying to get it working right now. YouTube is giving me some stream health problem notifications here, but I don't see why. All of my stats and dashboards look good. If anyone is seeing any problems, do let me know. Yeah, it says it's buffering on my side too. This is a good enough opportunity for me to just take a quick break. I'll be back in just a couple of minutes here. All right, cool. Oh, thanks, Anarch YX Ninja Fan. Let's see. Well, get back to this. I'm gonna try reading the hours, and then we'll see where we are. I'm kind of curious if 24-bit mode is by default turned on or not. Bit 6 of the hours register is defined as the 12-hour, 24-hour mode select bit. Oh. Okay. So it seems that I really do like this little, to be able to just kind of peek a field real quick. Oh. I broke something badly. Someone probably saw it. What did I miss? Right byte declared as array? Oh, missing an equal sign. So this will be our first test of being able to read and write a byte, I guess, on the 24-hour timeline. Default is 24-hour mode, you say? I guess we'll check it real quick and then I'll try to read. So if it's in 24-hour mode, then I need to read the bottom 2 bits plus the hours here. And all right. So it didn't zero pad it like I wanted it to. Do that real quick. But it's saying that just the last 3 bits are set. So that's saying that the 10 hour isn't set and that this bit is not set, which says to me that that's currently in 12-hour mode. Yes? The hours value must be re-entered whenever the 24-hour bit mode is changed. All right. Yeah, that's definitely saying that it's not in 24-hour mode right now. And it's also saying that I'll be resetting the 24-hour time if I do. I'm sorry, I'm reading the comments. Why format lib doesn't validate my parameters to the format function? I thought the C++ was kind of... it is possible, yeah, you're getting answers from other people. Ah, good old C++. Let's see, do a bitwise OR of a byte with a byte's width amount of data and get back out an int, of course. Something tells me I'm not going to get to the screen today. I'm probably not going to do this terribly much longer for today's live stream. Hey, Ollie. For those of you just joining us, we are playing around with some I2C devices, and I may as well just go ahead and do a quick overview. I have currently disconnected my 9-axis sensor, and I have a 12 by 32 OLED display, which I am not trying to write to at the moment, and a single board RTC and Eeprom. The RTC we have working. There we go. Okay, that's definitely not quite doing what I expected it to do. We'll have to look at that in a moment. And there's an Eeprom RTC on here, and we're reading the current timeout. Now I'm saying this is definitely not working because, well, this board hasn't been booted for 4 hours. I'm pretty sure it hasn't. Oh no, it does look like. Oh yeah, it has been saying 4 hours this whole time. Weird. Huh. I should put a battery in this so whatever time I set it to actually stays. All right. Well, that seems to be working. Yeah, the link step does take ages. I am on a Raspberry Pi 2. Maybe I'll order a new Raspberry Pi to play with for this stuff. 6-bit of the hours register is defined as a 12-hour, 24-hour mode select bit when high. Yes. Oh, when high, the 12-hour mode is selected. Really? Oh, hey, look at that. That is what that says. That's kind of funny. So, huh. All right, that works, and it seems that we can read and write values to it. Let's, just for the fun of it, try to read and write some values to the RAM that we have access to, because we have RAM. And I guess that RAM would be persistent if I had a battery in it. So that's interesting. That gives us an extra 56 bytes of RAM. I don't know, what value should I write? 42? Ooh. Command value, read byte, write byte, read byte, block data. All right. I'm not going to mess with that at the moment. And just a reminder for those of you just now joining us, I don't have any idea what I'm doing at all. I just thought it would be fun to stream some hacking on a Raspberry Pi with some I2C devices. And we're getting somewhere. There's a comment here asking me if I'm sure that my this device was actually connected because it looks like I have a breadboard with split power rails. I'm almost positive that this was connected. Yeah, I see what you're suggesting. Yeah, all right. I read and wrote 42 to the RAM there. All right. I don't know if these tips. Huh. Well, that's interesting now, isn't it? Huh. I don't have a MacBook. I use a MacBook. Don't mind me, I'm just getting some jumper wires to connect the two sides of my bus here to see what happens. This, by the way, since you just asked, is not the laptop I'm programming from. This is the laptop that I'm actually using for monitoring the stream. And the laptop that I'm actually programming from is a ThinkPad. This is also a ThinkPad. This device is also a ThinkPad. All right, so I've got 1, 2, I need to get a couple more jumper wires here. I had no idea that that had a split rail, so thanks. My other breadboard, as far as I know, doesn't, but it could explain other problems that I've been having. Now remember, always work with live power. So where's the actual split? Is it here at pin 30? Let's see what happens. I see where the colors are split. Okay, that's smart. And so I need to tie this one, sorry about hitting the microphone, back to high here and jumper across here and here and volts there. And now power my MPU back on. All right. Oh yeah. I think just for the record, that's all at 3.3 volts. The chance of danger here for me was extraordinarily low. 3 volts with basically no current. Worst thing that would have happened probably would have been rebooting the Raspberry Pi. Hey, look at that. We have all 4 devices visible now. So we know that 69 is the MPU, 68 is the RTC, 50 should be the Eeprom, and 3C should be the OLED display. All right. See? This is why we do this kind of thing. Because it's fun like that. Whatever. Okay, so I did a little bit too aggressive of a search and replace, but it's fine. Actually, yeah, 50 is the Eeprom. All right. Where do we go from here? Let's say I'm going to spend another 45 minutes at this. I don't have pull-up resistors because I believe that the I2C bus on the Raspberry Pi has internal pull-up resistors. I'm pretty sure. I could be wrong, but I'm pretty sure that's right. Wait. Okay, so the ARM processor doesn't have internal pull-ups, but the board supposedly does. So, well, just to clarify for the sake of the comments that are going past right now, it looks like it's not the processor that has internal pull-ups, but it is the board as built by Raspberry Pi that has the pull-ups, perhaps. So I think we're all right, regardless. I don't think we would get nearly as far as we have so far if the lines were floating all over the place. All right. All right, so we have an RTC device of some sort here. Oh, no, wait, I have no idea how that's going to work. I just realized something. I have no idea how this works. So if I'm going to open this device for read-write, can I open it multiple times for read-write in the same process? I guess I should be able to, huh? I'm going to do something to satisfy my own curiosity. All right, so that is sitting here streaming an animation to that. And I can still detect the devices. But I can't read the clock back. Wait, what is happening? What in the world? I have to use SMBus, not I2C as a file directly. Okay. What is going on? My RTC did not like whatever it was that just happened here. Is it because I'm... No, this was all working. It's like 1 second for every hour is passing right now. I keep No, I shouldn't be resetting the clock because I'm only writing the hour, and it only said that I had to rewrite the hour. No? All right. We're going to comment that out. We're going to assume it's in 24-hour mode. We're going to recompile this, but I don't think that's the problem. I feel like something got unhappy while I was messing with the power bus, but I could be wrong. Oh, see, look at this. This is what happened. You all didn't catch this. This is the wrong number of arguments passed to format. It's unfortunate. All right, so reading and writing from the Eeprom. Okay, I feel like we have successfully decided that we can read and write this device. This doesn't seem very exciting, relatively speaking. Talking to the Eeprom could be moderately interesting. All right, yeah, that's fine. That's fine. So I think the Python code, just for the record, is actually using the exact same kernel interface that I am. It kind of seems like the kernel is moderating the writes over the bus, reads and writes over the bus. That appears to be what's happening. Oh no, wait. So I have an LOL, I told you so. Where was that? Did I miss it? I don't see it. All right. Now, format lib doesn't, well, it does if you have too few arguments. It's going to give you an error. The problem is that it doesn't have the same kind of internal compiler hooks that printf has. Printf cheats, right? Well, it doesn't cheat directly, but the compiler cheats because the compiler pre-processes the format string to printf and then checks all of the parameters that you're passing to it. Our compilers don't have the same kind of cheats in place for lib format at the moment. They probably will at some point in the future. All right. So that's up on the GitHub if anyone cares. All right. Yeah, surely it's possible. Well, it is true. The compilers, yeah, it's cheating. It's because we knew that it was so much of a source of. Now the difference is if you do something wrong at runtime with printf, then you end up with a cert being assigned to you, basically, because you've now introduced some sort of security flaw, likely. If you do something wrong at runtime with lib format, then you get an exception thrown, which isn't ideal, but it's also not the same thing. So I'm pretty much okay saying that the compiler's cheating, but it's cheating on our benefit. Yeah, you can use format compile, but how much more would that slow down this build that we've got already going on? All right, so trying to initialize the 128 by 32 thing. I'm looking here. This is cheater code that I know can work, and this is just sending one command. Now, as I understand the I2C SM bus, when you say write byte data, this command followed by a value, it's basically just sending 2 bytes. It's sending the byte that is the register that you want to read from, and then it is sending the byte that is the value. Now, the SSD 1306 here, this interface, doesn't use that register read write. It just like sends bytes and read bytes. So to send a command here, it's sending a 0 followed by the value. So this would be equivalent to sending, yeah, this write 8 is the same thing as the SM bus register write, saying theoretically it's like the same thing as saying I'm writing to register 0 and I'm sending this bit. So that's how it's setting up all of these commands here. So I can attempt to set these same commands and clear the interface and whatever. Now the question is, I don't know what VCC state I should be using. Switch cap VCC. Initialize, clear, display. Okay. Okay. I'm totally cheating on this one. Set DC high for data, right, all right. I don't have external VCC. All right. I'm being told I don't have external VCC. I'm just going to yoink this. What was that set paste option that someone told me about before? Oh, just set paste. Ah, I see. I'm in paste mode. Got it. Yes, please. Oh, look at that. That's not that bad. Oh. Better. Oh, no, the lines on the display are, yeah. So for those of you who are just now joining us, I've been playing around with these examples off and on. Like that. So they're examples from the Python library that I'm currently copying and pasting from. Wait, what is this? SSD 1306 switch cap VCC. O2. This is saying if I don't have external VCC, then I need to set F1. I can't play music, just for the record, at least every time I try to play any kind of music, even if it's stuff that it's completely free, I totally get a copyright ding on YouTube, and I just hate dealing with YouTube for that kind of thing. All right, display off, set display clock div. Let's just steal a little bit of these. Oh, not very much. That's fine. So this display driver has all kinds of things, like its own ability to scroll and whatever built into it as well. It's pretty cool. Oh, I did that wrong. All right. So I've got those constants available to me now. I'm reading the comments. Switch cap VCC to generate the display voltage step up from the 3.3 volt source. Oh, okay. Or external VCC otherwise. Got it. Got it. All right. So interesting. So what value is it actually setting here? It sets the charge pump. So I'm just looking at the library that works right now, right? And you're saying O2, switch cap VCC, charge pump is AD. It's not actually setting any values on it. It's setting pre-charge and then setting a command 22 F1. Okay. Yeah, I see all of your comments here about paste mode. I'll take it out in just a second. I think I'm done So all of these commands are things that are 0 followed by a value. Let's right. So the commands, though, these things are all a 0 byte followed by the value for control commands. That's the nature of this SSD thing here. That's the that's this one. I2C interface. Here, right? So it's the thing followed by the control byte followed by whatever you want it to do. And this ends up being, well, more complicated over I2C than it is over the other possible interfaces. Well, not more complicated. It seems just more annoying. I think that is yeah, I know that's regex, whatever. Not file, device. And I should have captured that. Device. All right, cool. My hobby is programming with regular expressions. So we know that it's not external VCC, so I'm just going to leave these commands how they are. And thank you for that input here. So theoretically, I can call this thing and init this device, and it'll be running. Well, that's unfortunate, isn't it? Because I named that thing RTC. Whatever. Yeah, you already caught my mistake, didn't you? All right. Usually keep stream recordings. Yes, I will. Register 0, command register. Yes. Okay. Save the record. Yeah. Absolutely. It'll be up. And I'm got something going on here where oh, right. By the way, I did, if anyone is curious, talk to the Sea Lion, some of the Sea Lion team about the possibility of running Sea Lion on a Raspberry Pi 4, because I figure by the time you've got a Raspberry Pi 4 with 8 gigs of RAM, you should be able to run a full IDE if you really want to, but it seems that's not possible at the moment, although it really seems like it should be to me, because they have ARM support now on macOS. So I expect a clear maybe display, or I expect this display to at least flicker as it turns off and back on again. Did anyone see anything happen? No, I didn't see anything happen either. It went all the way around. It should have written to that device. Well, all right. So let's just say theoretically, because it didn't clear the memory, that it did all of that and then left the display back in its original state, and it all happened so fast that we didn't see anything change. So I'm going to see if I can just turn the display off again. Whoever's asking, have I tried Qt Creator? If you were asking me, I have, in fact, used Qt Creator a long time ago. I haven't tried it in a while. Okay, it clearly is not sending this command like I think it should be. So it should be sending to this. Oh, it's sending all of those values to the real-time clock, which should be obvious because I did in fact say send it to the real-time clock here. But I should have set the IO control What is that device address again? 3C. I wonder if I can do that. Multiplex the same. I know this is terrible, terrible hack at the moment. Hey, I turned off the display. That might be enough just for me to call this something, because I clearly have to clean this code up. I'm so just itching curious now. I have to know. It does take a lot to write the single line to the OLED. I am going to do this. Okay. I have no idea if I can if I can dupe the file descriptor and then set the ioctal on it. I really have no idea. Dupe would probably make more sense, but yeah. I'm also just kind of leaking a file handle right now, aren't I? I'm creating the, let's see, what am I actually, oh, I'm not returning anything from this function. Oh, and look, and the compiler is getting ready to warn me right here too. Oh, come on. Yeah, thanks, Baron the Colossus. Seriously though, if the display turns back on right now, then I'm gonna feel like it's time to stop for the day because I'm getting tired, and we'll have actually, oh wow, and it's really nice walking weather. I need to go on a walk. The display did not turn back on. Shoot. Normal display. A set there. If someone's asking me for best practices on embedded systems, I am the wrong person to ask. Write PMR allocator, which uses I2C memory. Might be able to do that. Okay. All right. We can see the display flicker because I have done display back on again. I'm going to put it in all on mode, which should make all the pixels white. And then I'm going to quit it. And then we'll come back to it maybe in a later stream, and we'll see about doing something more to it. Yeah, the last time I did embedded development professionally was in like 2006. And I haven't really messed with it since then. I keep buying stuff like this, hoping that I'll actually use it and make some fun projects, but then I don't. Hey, all on worked. All right, cool. And then, yeah, we'll keep playing with this later, not today. All right, cool. That was fun. Thanks for joining me, everyone. I don't know how many people we ended up with today. It says concurrent 150 at the moment. That was pretty cool. Thanks for the tips. And I will catch you all later. Thanks again. Oh yeah, I have lots that I need to do to make this better. Yes, this is not best practices development at the moment. This is hacking and trying to get something work. All right, good night, everyone, or good day.